All right, remote calculus, welcome to first video here on antiderivative. So given the original function, which is f of x, is x squared minus 3x plus 8. That is the original function. First, we're just showing the difference between a derivative and an antiderivative. So f prime of x is the derivative. Bring down the exponent, 1 power less. X to the first, so bring down the exponent, 1 power less. Derivative of a constant is 0. So the derivative would be 2x minus 3. The antiderivative, just doing the opposite operation. So if the derivative, we subtracted a power and brought down that original power as multiplication, what we're going to do is we're going to, again, this is the original function, we're going to add 1 to the exponent and then divide by the new power. So in the antiderivative, take this original function, we add 1 to the exponent, 3, and then we divide by that new exponent, 3. Minus, we add 1 to this exponent, 2, and then we divide by the new exponent, 2. Plus, this is really like x to the 0, so we add 1 to the exponent, x to the first, then divide by 1. Now we put this plus c, it's called an arbitrary constant, because if I were to take the derivative of this function, derivative of c, a constant, would be 0. All right, there's any arbitrary constant involved with an antiderivative. Again, if I take the derivative, that is what this apostrophe means. If I take the derivative of the antiderivative, let's see what happens. Here's the antiderivative. If I take the derivative, I bring down the power, 1 power less. That would cancel to be x squared. I bring down the power, so 2 times 3x divided by 2. That cancels. 1 power less. I bring down this power, 8 times 1 is 8, 1 power less, so x to the 0. That gives me my original function. So again, the derivative, so an antiderivative is a function such that when I take its derivative, I get back to the original function. All right, oh, don't forget about, this, what's the derivative of, a constant? Derivative of a constant, 0. That's why nothing's there. So that is what we're going to do for a few questions here. Given f of x, find the derivative and antiderivative. So f of x is 2x to the third minus 4x squared plus 7x minus 3. The derivative would be, bring down the power, so 2 times 3 is 6, 1 power less, x squared minus, bring down the power, 4 times 2 is 8, 1 power less would be x to the first. Bring down the power, 7 times 1 is 7, x to the 0, just 7. The derivative of any constant is 0. That is the derivative right there, 6x squared minus 8x plus 7. That's the power rule with derivatives, and there exists that sort of rule with antiderivatives. So taking the antiderivative, I add 1 to the exponent, so 4, and I divide by the new power, minus. I add 1 to the exponent, 3, and I divide by that new power, plus. I add 1 to the exponent, 2, and I divide by the new power, minus. This is again like x to the 0, so I add 1. It'd be x to the first, divide by that new power, plus this arbitrary constant. Again, it simplifies to be that. If I took the derivative of this function, it would be 2x to the third minus 4x squared plus 7x minus 3, which is my original function. Again, derivative of this arbitrary constant is 0. All right, so f of x is sine x. The derivative of sine is cosine. So my derivative is cosine x. My antiderivative, so with the antiderivative, I ask myself, what do I take the derivative of to get sine x? So I'm going backwards here. I take the derivative of what to get positive sine? I know the derivative of cosine is negative sine. So the derivative of negative cosine would be positive sine. So the antiderivative of sine is negative cosine and then plus c, the arbitrary constant. And here, this is integral. We'll talk about that later. So this is an indefinite integral here. That's the independent variable, x. So dx stands for the independent variable is x. The antiderivative of sine is negative cosine, because if I take the derivative of negative cosine, I will get the opposite of negative sign, which is positive sign. All right, we're just going to give these special ones here. So next one, if f of x is cosine x, the derivative is negative sine x. Derivative of cosine is negative sine. So what's the antiderivative? All right, again, if I know the derivative of cosine is negative sine, I know the derivative of sine gives me cosine. So again, I ask myself, if I'm looking for the antiderivative of cosine, I take the derivative of what to give me cosine? I take the derivative of sine to get cosine. Again, plus that arbitrary constant. When I have an indefinite integral, no bounds, you might not, again, we'll know what that means later. The derivative of cosine is sine. If I ask for the general antiderivative, you need plus c, that arbitrary constant. Again, when I take the derivative of a constant, get back to cosine. All right, so f of x is secant squared x, which is actually not the easiest derivative to take. Going to have to use, that's secant x squared. Right, gonna have to use the old chain rule, 2u, then I have to take the derivative of secant, which is secant x tan x. This would be 2 secant squared x tan x. I know the derivative of tangent is secant squared. All right, so I take the derivative of tangent to get secant squared, and that's, again, what you're looking for in an antiderivative. I take the derivative of what to get secant squared? So the antiderivative of secant squared is tangent x. Again, if I'm looking for the general antiderivative, I put plus c. Capital F of x stands for the antiderivative. Lowercase f of x is the original function. F prime of x is the derivative of the original function. So f of x is secant x tan x. If I wanted the derivative, I have to do the product rule. Derivative of the first would be secant tangent times the second plus the first. Derivative of the second. Again, I take the derivative of what to get secant tan? I take the derivative of secant to get secant x tan x. So the derivative of... That is not right. The antiderivative of secant x tangent x is secant x. All right, I wrote something wrong there. That is now right. The antiderivative of secant x tangent x is secant, because the derivative of secant is secant tangent. Sorry about that. E to the x is fun because its derivative and antiderivative are the same thing. Only got that arbitrary constant there. The antiderivative of e to the x is also e to the x. We'll do some more things with that later. If the derivative of natural log is 1 over x, then if f of x is 1 over x, its antiderivative is natural log x plus c. So the antiderivative of 1 over x is natural log x plus c. So now we got a bunch of questions. Just says find the general antiderivative of f. So f of x is that. So I'm going to divide everything by x, take a power away. All right. I'm going to rewrite 8 over x as 8 times 1 over x, because it is that. All right, so both of these are going to involve the power rule for antiderivatives, and again, this one is special. Okay, the power rule of antiderivative says I add 1 power and I divide by that new power, so I add 1 power to 2, that's 3, and then I divide by 3, minus, I add 1 to this exponent, so that's 2, and I divide by 2, plus antiderivative of 1 over x is natural log x. So this would be 8 times the antiderivative of 1 over x is natural log x. See, you don't want to write it like this, because if I add 1 to the exponents and divide by that, that's no bueno. That's undefined. So that's why I need to write it as 1 over x, because the antiderivative of 1 over x is natural log x, because the derivative of natural log x is 1 over x. All right, so on this one, what I did was FOIL it up and then simplified. 1 power up divided by the new power minus 1 power up divided by the new power plus 1 power up divided by the new power plus c. Cool, there we go. Ten x to the 1/2. That's the square root of x. So I'm going to add a power. If I add 1 to 1/2, that is 3/2. I'm now going to divide by that new power plus c. If I divide by 3/2, that's like multiplying by 2/3. So this is the proper way to give that answer. Again, if I take the derivative of this, 2/3 times 3/2, that's 1, and I subtract the power, I get back to x to the 1/2. You can always take the derivative of your antiderivative to check your answer. All right, number 11 here. There's the original function. I rewrote it as the following, okay? The antiderivative, again, which is capital F of x. I add 1 to the power. Add 1 to -2, that's -1. Then I divide by -1. Plus 4, the antiderivative of 1/x is natural log x. This is x to the 0, so I add 1 to the power. It'd be x to the first. I divide by 1, which is 7x, plus this arbitrary constant. I need to rewrite this as a -3/x plus 4 natural log x plus 7x plus c. All right, so we see a lot of these. I'm going to rewrite the cubed root of x plus 2 times the square root of x as x to the 1/3 plus 2 x to the 1/2. I'm going to add 1 to this. That's 4/3. I'm going to divide by 4/3. Plus, I'm going to add 1 to this power. That's 3/2. I'm going to divide by 3/2. Plus this arbitrary constant. Again, if I'm dividing by 4/3, I'm really multiplying by 3/4, the reciprocal. And if I'm dividing by 3/2, I'm really multiplying by 2/3, the reciprocal. And it simplifies to be that. On 13 here, 4 times this squared. So I squared it, multiplied everything by 4. 1 power up divided by the new power minus 1 power up divided by the new power plus 1 power up divided by the new power plus c. Simplify what we can. Next page. Last page here. My function is 2 cosine 3x. Oh, man. So, again, I asked myself, I take the derivative of what to get cosine? I take the derivative of sine to get cosine. So, the antiderivative of cosine is sine. Now, if I were taking the derivative of sine 3x, I would multiply by 3. So I'm going to do the opposite of multiplying by 3. I'm going to multiply by 1/3 or divide by 3. Okay, so this is not just x, it's 3x. So again, if I were taking the derivative, I would multiply by 3. Instead, the antiderivative is doing opposite, so I'm dividing by 3 or multiplying by 1/3. That's why I get that. Again, I can take the derivative of this. If I take the derivative of 2/3 sine 3x, it'd be 2/3 derivative of sine is cosine 3x. Then I take the derivative of 3x, which is 3. 2/3 of 3 is 2. Gets me back to my original, plus c. Don't forget about the plus c in there. Again, the derivative of the derivative of a constant is 0. That's why it went away here. All right, here on 15, let's take a look. F of x is 4 secant squared x minus x squared. Antiderivative of this one here is easy. Add 1 to the exponent 3, divide by 3, plus the arbitrary constant. For the derivative of tangent is secant squared, so the antiderivative of secant squared is tangent. Again, I take the derivative of what to get me secant squared? That's tangent. So that's a pretty quick one. On 16, I got 2x plus 3 over x, or 3 times 1 over x, minus the cubed root, the 4th root of x, or x to the 1/4. Add 1 to the power, divide by the new power, plus 3, the antiderivative of 1 over x is natural log x, because again, the derivative of natural log x is 1 over x, minus 1 power up, that's 5 over 4, x to the 5/4. Instead of dividing by 5/4, I'm going to multiply by the reciprocal, 4 over 5. This would just be x squared. 2 left. F of x is 3x to the 3rd minus 2x squared plus 8x plus e to the 2x. 1 power up divided by the new power minus 1 power up divided by the new power plus 1 power up divided by the new power plus antiderivative of e to the 2x is e to the 2x. Again, if I were taking the derivative of this, I would multiply by 2, the derivative of 2x. Instead, the antiderivative, instead of multiplying by 2, I multiply by half. And 18, same type of deal. Antiderivative of 3e to the u would be 3e to the u. And instead, if I were taking the derivative of this, I would multiply by 1/2, which is that derivative. Instead, I'm going to multiply by 2. Here would be my answer. Again, I can check it by taking the derivative of this. It would be 6e to the u. Then I would take the derivative of u, which in this case is 1/2. And look at that, I get back to my original. And again, I forgot about c for my antiderivative. If I take the derivative of a constant, that's 0. So that's why it goes away here. That should be enough help for your first homework set. This is Yak Math Videos, signing out.